Black holes are regions in space where the gravitational pull is so intense that nothing, not even light, can escape. They are the most extreme objects in the universe, making it difficult to describe their awe-inspiring nature. They simply defy human comprehension. Hello and welcome to ZE. Please don't forget to subscribe and hit the bell icon. Consider their size. Our solar system includes 8 planets, 5 dwarf planets, over 200 moons, and more than 1 million asteroids. This seems vast, but compared to the Sun, it's minimal. The Sun, with its colossal mass of 2 million trillion kilograms, accounts for 99.8% of the solar system's mass. Yet, the largest black holes can be up to 50 billion times more massive than our Sun. If you could place the Sun on scales at a rate of 1 per second, it would take more than 1,500 years to equal the mass of the universe's biggest black holes. To put it in perspective, in terms of mass, the largest black holes are to the Sun what a rhinoceros is to a grain of sand. Star Trek Fleet Command offers a story-driven Star Trek galaxy where you can interact with characters from the next generation, the original series, the J.J. Abrams films, Discovery, and more. Engage in real-time combat in an open world, battle alongside allies to capture territory, pool resources, and dominate the multiverse. If you reach level 5 by February 10th, 2022, you'll unlock a free Origins Burnham and upgrade your Burnham to rank 2. I particularly enjoy the extensive research trees that allow you to specialize your fleet, conquer the multiverse, and earn Battle Pass rewards. Whether you prefer playing solo or in a team, there's a mode for you. The game includes base building, space battles, quality graphics, and of course, Spock. Remember, Star Trek Fleet Command is free to play on iOS and Android, so use my link in the description below to download it today. Happy trekking! These enormous black holes, known as supermassive or ultramassive black holes, can consume entire solar systems as effortlessly as you might accidentally swallow a fly while jogging. Surprisingly, recent research suggests that planets might orbit some of the largest black holes in the universe, possibly many of them. So, how is that possible? And more importantly, could these planets support life? While it might seem improbable that habitable planets could survive near these terrifying giants, supermassive black holes aren't the intergalactic vacuum cleaners they are often thought to be. The idea that they suck everything around them into their gaping maws is one of the biggest misconceptions in our universe. Black holes don't suck at all. Objects are drawn toward them in the same way you are drawn to the Earth, through gravity, as long as you don't get too close. Unless you like the idea of being turned into human spaghetti, the gravitational pull of a black hole is the same as that of a star of the same mass. If you were to instantly replace the Sun with a black hole of equal mass, it wouldn't suddenly devour the Earth and other planets. They would continue to orbit the black hole just as they orbited the Sun. Of course, we'd all perish slowly and horribly as temperatures dropped and the oceans froze, but at least it would solve global warming. Thus, there's no reason why planets couldn't orbit a supermassive black hole. The question is, do they? It's generally accepted that planets form in the giant clouds of dust and gas surrounding young stars. Over time, dust particles within these clouds, known as protoplanetary disks, collide and stick together, forming planetesimals. When these chunks of space dust become large enough, their gravity attracts more dust and debris, eventually forming a planet. It turns out that some supermassive black holes are also surrounded by swirling clouds of dust and gas, known as accretion disks, similar to protoplanetary disks. Recent research suggests that under the right conditions, planets can form within a black hole's accretion disk in much the same way they do around stars. Of course, we're talking about different scales here. Supermassive black holes are much larger than stars, and so are the clouds of dust and gas that surround them. More building material means more planets, a lot more. Upper estimates suggest that a single supermassive black hole could have a system containing more than 10,000 planets. Well, not exactly planets, Scientists have decided to call planets that orbit black holes planets with a B. I wonder if they've noticed we don't call planets that orbit stars planets. That could be an awkward meeting. Anyway, these planets could be strange indeed, with the largest being up to 3,000 times more massive than Earth. That's about as big as a planet can get before it turns into a brown dwarf. Now for the crucial part. Could these colossal black hole systems and their enormous planets support life? First, a disclaimer. While I consider myself well-traveled, I haven't yet visited a planet, so it's hard to say for sure. But since the release of Christopher Nolan's Interstellar, a film featuring a planet called Miller's World orbiting a fictional supermassive black hole, scientists have taken a keen interest in the topic. This isn't just a fun thought experiment. The habitability of planets could one day literally mean the difference between life and death for our species. But I'm getting ahead of myself. When searching for life in the far reaches of space, we look for planets with surface temperatures that could support liquid water, as all known life requires liquid water. We have liquid water on Earth thanks to heat from the sun, but planets orbit cold, unforgiving black holes instead of stars. So, are they all just frigid rocks and ice? Actually, probably not. There are a couple of other potential energy sources near black holes that might provide enough warmth for liquid water to exist on a planet. While black holes emit no light, the area immediately around them can be incredibly bright. You've probably seen the famous picture of a black hole, the first ever taken. That glowing ring around the outside is the black hole's accretion disk. As matter from the accretion disk is consumed by its parent black hole, it's accelerated to incredible speeds, up to half the speed of light. The energy released through friction is immense. If a planet is the right distance from a supermassive black hole, the accretion disk could provide enough warmth and light to support liquid water and life. However, there's a problem. Accreting supermassive black holes are among the brightest objects in the universe. The largest, known as quasars, can be thousands of times brighter than the 400 billion stars in the Milky Way combined. A single black hole can shine with the light of thousands of galaxies. Quasars can also be incredibly hot. One, named 3C273, has a temperature of 10 trillion Kelvin, 1.5 billion times hotter than the sun's surface. So, while an accreting supermassive black hole could potentially provide the warmth needed for liquid water, it could also melt nearby planets into interstellar slag. Fortunately, not all supermassive black holes come with world-ending accretion disks. Around these comet giants, another potential energy source might come into play. But fair warning, things are about to get seriously weird. This mystery energy is the electromagnetic radiation left over from the Big Bang, known as the cosmic microwave background. The good news is, the cosmic microwave background is the biggest source of radiation in the universe. It's everywhere. The bad news is, it's extremely cold, just a few degrees above absolute zero, like outer space. But physics has a trick up its sleeve. As the cosmic microwave background is pulled into a black hole's gravity well, it becomes blue-shifted, increasing its energy. This means that the closer you get to a black hole, the hotter the cosmic microwave background feels. It's possible this could create a kind of Goldilocks zone around a black hole, warm enough to support liquid water. However, this Goldilocks zone, let's call it the Goldilocks zone, is likely dangerously close to the black hole's event horizon. The gravity would be extremely strong, and a planet would need to orbit the black hole very quickly to resist it, practically at the speed of light. Whether that's possible is debatable, and even if it is, it brings issues due to special relativity. High speeds and strong gravity cause time dilation, making time slow down. On a planet moving near the speed of light just beyond a supermassive black hole's event horizon, time would move incredibly slowly, potentially tens of thousands of times more slowly than on Earth. While time always feels normal from your own perspective, extreme time dilation could affect life's development. In Interstellar, every hour on Miller's World equaled 7 years on Earth, a time dilation factor of about 60,000. Life on Earth emerged after roughly 500 million years. But for 500 million years to pass on a planet with a time dilation factor of 60,000, the universe would need to be at least 30 trillion years old. It's not. So, even if life could exist on a planet where the cosmic microwave background supports life, a big if, it probably hasn't had time to evolve. While there's a reasonable chance giant black hole systems exist, what they look like and whether they could support life is still unknown. Our current understanding is based on many assumptions, and if those are wrong, our conclusions will be too. But whether life could exist on a planet isn't just idle speculation. It could be crucial for us humans. One day in the far future, about 100 trillion years from now, star formation will end. In 100 trillion years, as the remaining stars fade, the universe will go dark. When that happens, we humans might have to head for the nearest black hole, the last sources of energy in the dying universe. Whether we can survive there is a big deal. Okay, I might be getting a bit ahead of myself. Our species might not make it through the next 100 trillion years, or even the next 100 years. But hey, it's always good to be prepared. Thanks for watching.